Alright, so here we go. Math 152, Statistical Methods, Module 3. Chapter 5, Normal Probability Distributions. So, as a reminder, a continuous random variable has an infinite number of possible values that can be represented by an interval on the number line. Its probability distribution is called a continuous probability distribution. So, pretty much, continuous, I hope I spelled that right. Probability distribution. I try to do too many things at one time. Here we go. Probability distribution. I did see it. It's right there. Next line. Continuous probability distribution. So in chapter 4, where we just finished in module 2, we were looking at the discrete probability distributions and how do we calculate. So with discrete, we have a cap. There are only whole numbers that we're working with. Continuous, we're working with all the numbers in between. So we don't just have $1 and $2. We have $1.05, $1.10, $1.23. So we have to calculate all those probabilities. It's going to be a little different, but we can still do it. So the most important continuous probability distribution is called the normal distribution. Normal distribution. And let's talk about the properties of a normal distribution. So it's a continuous probability distribution for a random variable x. So that means our data is continuous. Remember, we have numbers that are in between. So in between 5 feet and 6 feet, we have 5 feet 3 inches, 5 feet 4 inches, and so forth. So that's continuous data that we're taking in. They have decimals in between. The graph of a normal distribution is called the normal curve. You've probably seen this in a lot of graphs and didn't know what it was, but this is the normal curve. In a normal curve, which is symmetric, remember we learned that it's symmetric. We can cut this in half and fold it over. The mean, median, and mode are equal. So the mean, the median, and the mode are equal. The normal curve is is bell-shaped and is symmetric. We just talked about that. Symmetric about the mean. So we always look at everything in terms of the mean. Where is it from? Well, we base everything from the middle of our graph for the mean. Okay. The total area under the normal curve is equal to 1. So we still have that same concept as discrete probability, where all of our probabilities should equal 1. Same thing here. The normal curve approaches but never touches the x-axis as it extends farther away from the mean. So that means that this graph, when we graph it, will never cross that x-axis because we can't have a normal probability. So this represents our probabilities. If we come down here, that means we have negative probabilities, and that's not possible. The points at which the curve changes from curving upward to curving downward are called inflection points. So when we're looking at our graph and it starts going from decreasing to increasing, or when it starts, not increasing, decreasing, increasing, but when it starts changing, whether it's upward or downward. So like this is our down part of our curve, and then this actually starts going up at this point. So it's right about here, starts being upward, and our lower part comes down. There we go. Property density function, or PDF. A discrete probability distribution can be graphed with a histogram. So for the last chapter, in chapter 4, we graph using the bars. For continuous probability distribution, what we're doing now, you can use a probability density function. Okay, so that means we're going to be curving. A probability density function has two requirements. The total area under the curve must equal to 1, and the function can never be negative. So it still has those characteristics. It's just listing it out this time. So remember, with probability distribution, we had to check to make sure they all added to 1. And we have to check to make sure each of those probabilities were between 0 and 1. Same characteristics, just write it out this time. All right, means and standard deviations. So normal distribution can have any mean and any positive standard deviation. The mean gives the location of the line of symmetry. That means it's the middle of our graph. The standard deviation describes the spread of the data. So the definitions are the same as we learned them in the basics in module 2. Well, module 1, excuse me. Yeah, it's been a while. Module 1. And we're going to look at it in terms of the graph. So let's talk about the standard normal distribution first. So standard normal distribution is a normal distribution with a mean of 0 and standard deviation of 1. So you will always have this characteristic with the norm or the standard normal distribution. So the standard normal distribution means that everything, all your data points are converted to z-scores, and everything is on an equal plane. So you know how we can compare like money, we can compare height, we can compare or have data as things, you know, with decimals in it pretty much. Length. So that means that, you know, we can turn all that data into z-scores, and those z-scores will always have these same numbers: 0, 1, 2, 3, -1, -2, -3, and then all those numbers in between. So remember, z-scores are exact standard deviations. So that means any x value in your data set can be transformed into a z-score by using the formula. And this formula was in chapter 1, and it's again here in chapter 5 or module 3 of your formula sheet. Let me bring it out real quick. So we learned it in chapter 2 in module 1, but again, we're going into detail with this in our formula sheet again in this chapter. So again, when we're talking about standard normal distribution, we are converting any data set that we have into z-scores. We turn the data set into z-scores, and we're trying to find out where the mean is, and then convert everything in terms of how far is it from the mean. So that way all of our numbers look the same when we're working with them. So we don't have money, we don't have feet, we don't have inches, we have standard deviations for everything. Okay? So the standard normal distribution is a normal distribution with a mean of 0, standard deviation of 1, and the total area under its normal curve is 1. So I'm just repeating that so we can see what all that means. So sorry, this is my janky graph. I did the best I could. So this graph represents the standard graph that standard normal distribution always uses. These numbers will always be on the bottom. So 0 is in the middle, z equals 1, 2, and 3, and z equals -1, -2, -3. So that will always be the case. All right, so next we talk about the properties of standard normal distribution. Try to get this at the same time. So the cumulative area is close to zero for z-scores close to z equals negative 3.49. So let's look at that. So if my z-score is negative 3.49, it's down here somewhere. So I don't have anything shaded that I can see. So that means my probability is zero or really close to zero. So like 0.0003 or 0.0001 or something like that. The cumulative area increases as a z-score increases. So if I get to z equals negative 2, I have a little bit more shaded area. So that means my probability is getting larger. The cumulative area for z equals 0 is 0.5, and that makes sense because from here to here, that's half of my graph shaded. So from here to here, that's half. So half of a probability, so half the probability, so 0.5. And again, as it increases, 0.5, maybe it's going to go to 0.75, 0.8, 0.89, all the way to the end. So the cumulative area is close to 1 for z-scores close to z equals 3.49. So down here z equals 3.49. That means from here to here, that's almost my entire graph shaded. So my probability should be really close to 1. Okay, so hopefully that makes sense of how we actually calculate or come up with these probabilities. So now, and we use that to just make sure our answer makes sense. So if we're talking about a smaller z-score, then our answers should be below 0.5, or negative z-score, excuse me, below 0.5. If we're talking about a positive z-score, it's going to be above 0.5. So from here to here, that was negative. So a negative z-score means I have a area or probability less than 0.5. If it's a positive, that means it's going to be above 0.5. So you always check your answer to make sure it makes sense. And we're going to learn how to shade in a minute. So let's look at our first problem. How to solve our first problem, excuse me. All right, so finding cumulative area. And we're going to, anytime we have area, you're going to round to 4 digits. Anytime we have area, we're going to round to 4 digits. So first is option 1 is table 4. Table 4 your formula sheet. If you want to pause and get your formula sheet real quick, you're going to need it. All right, find the whole number and 10th digit in the left hand column and then move across the row to the column of the 100th digit. Okay, so let me show you. So they're going to give you the z-score. This is the negative side that I'm working with first. Remember, negative z-scores means that my z-score is going to be between 0 and 0.5. And cumulative means we're starting from the left. Start from left to right, reading like a book. You're going to look to see what your whole digit and 10th is, and then line it up with your 100th digit. And that is going to be your probability or your area. Okay, we're going to practice it, of course. In your calculator, we're going to go to second bars and normal CDF. So normal, because we're using normal distribution. So second bars And we only use normal CDF in this course. So binomial, we use binom CDF, binom PDF. We only use normal CDF in this course. So how do you put those numbers in? So with normal CDF, it's going to ask you, okay, where do you want me to start on your graph? Where do you want me to end on your graph in terms of z-scores? And then give me your mean and standard deviation. And it's going to calculate your area for you. So lower bound is where you want me to start. So it's going to be negative 10,000. If your graph doesn't tell you to start anywhere, it's going to be automatic negative 10,000. If it tells you to start in a specific part and then go to the right, then you're going to put your lowest z-score in there. But normally we're going to use this. Upper bound is where you're going to tell it to stop. So normally you're going to put your z-score in for your upper bound. If we're stopping on the right and we don't have a stopping point, we're going to put it in 10,000. So we have to tell the calculator to start and stop somewhere. And if it's just a shaded region where it's starting or stopping, we're going to put that 10,000 in there. So don't forget, when you're putting your 10,000 in there, this is a number line. So negative 10,000 can go down here if you're starting down here. Even though my graph says -3, I need to start beyond -3. I need to tell the calculator to go as low as you can go. So negative 10,000 is normally what we put in. Some calculators will automatically have a low number in there. You can keep that and use that. If we have to stop on this end, like if we're shading and it's telling us you're going to keep shading and shading and shading. My graph stops at 3, but I can't tell the calculator to stop at 3 just because my graph stops at 3 here. We're going to tell it to stop at 10,000. So the calculator will keep going until you tell it to stop or start. So we have to tell it where to start and stop. For standard normal distribution, 0 and 1 will always be your mean and standard deviation. So for standard normal distribution, you may want to highlight this. Mean equals 0, standard deviation equals 1. It will always be your numbers. All right, so let's practice this first one. We're going to find a cumulative area that corresponds to a z-score of 1.15. So let me just pause right here because I meant to do this a little earlier, but let me state it right here. So area, probability are interchangeable. So they may give you a problem that says find the area. They may give you a problem that says find the probability, and they give you mean standard deviation. It's the same thing. Same thing. If they ask you to find a percent, they want you to convert your area or your probability to a percent. And remember, we just multiply it by 100, or we move the decimal places to the right. So if they ask you for a percent, just move the decimal place to the right and change it to a percent. Okay, so find the cumulative area that corresponds to a z-score of 1.15. So we're going to use the table first. Then we're going to use the calculator. So table. Pull out my table. So the one I used earlier, these were negative z-scores. I need to flip my paper to my positive z-scores. So I flip my paper to my positive z-scores. And I'm going to look for 1.1 and then line it up with my 5. Remember, we always look for the whole number and the 10th, and then line it up with the 100th spot. So let's do that. 1.1. Then there's the 5. I like using a table because it's kind of like a puzzle sometimes. I use it at first with the easy problems. Get down the road, a little harder. Not harder, just a little bit more work. Yeah. So 1.1 and 0.5 give us an area of 0.8749. That's it. Don't multiply it, don't divide it, don't do anything. That's it. So for z equals 1.15. The area is 0.8749. So I wrote that out that time like that so you can know um, exactly what that means. But this is how you're going to write your answer. Area equals 0.8749. And I want to check that to make sure it makes sense. So my z-score is positive. So my answer should be over 0.5. When I look at my graph, 1.15, that's a lot of my graph shaded. From here to here, that's a lot of my graph shaded. So that makes sense. Don't know what it is exactly, but it makes sense. Now, to use our calculator, let me pull this up a little bit. Remember, we want to find z equals 1.15. So I'm telling the calculator I need you to start down here and I need you to stop at 1.15. So that means I need my calculator to start at negative 10,000 because I don't have a starting point. But it did tell me to stop at 1.15. So cumulative means start here and stop wherever it tells you to stop. So 1.15 is like right here. So negative 10,000 to 1.15. We need to calculate all that probability, and that's what we're going to do. So I like to write the command in the calculator so that way you can see exactly what to put in. So normal CDF. Now the older calculators, you are going to have to actually put in the negative 10,000. Some calculators are going to have a negative 1E99 in there. Leave that. That's your lowest you can go. And my calculator has that, so I'm going to do that too. So 1.1501. Try to bring both of those in. So we're doing second bars. Number 2, normal CDF is 2 on my calculator. See, this is the calculator is negative 10,000. I'm going to leave that in there because I like it. 1.15 is my Z. So from my lowest Z to my highest Z, the calculator defaults to standard normal distribution. It defaults to it. So 0, 1, I don't have to change anything else but that one number. I confirm what I have on my paper is what the calculator is about to calculate. 0.8749. So the calculator is perfect. The calculator is perfect. It has a perfect answer. The paper is a finite answer. Those are rounded numbers. So your answers may be a smidgen off. They won't be too far off. They may be a smidgen off based on what your z-score is. All right, so there's the calculator gives you a perfect answer. The table is actually what the book uses a lot. So if you're going to need assistance with the calculator, you're going to have to contact me or your instructor to help you with the calculator part because the book normally works everything out with the table. Okay. All right, so let's build on what we just learned. So we just learned left only. So with the left only, we were just shading left to right. But now we're going to shade or calculate when we have other numbers other than the left and the right. So find the area under the standard normal curve. So remember, area, probability, and percent, all that is the same. So sketch the standard normal curve and shade the appropriate area under the curve. So first we're going to see, we're going to see what is shaded based on our problem. Then we're going to find the area by following directions in each case. So we could go from left to from lower end to the upper end, or from the middle of our graph to the upper end, or the middle of our graph. So let's look what that looks like. To find the area to the left of z, and this is also considered the cumulative. Also cumulative. What we just learned. This is left, so cumulative or default is left. Cumulative or default is left. Find the area that corresponds to the z in the standard normal table. So you use the table as is. So when you're sketching your graph, if it says left, you're going to shade left and keep shading until you get to your z-score. Okay, so I don't know what a z-score is, but whenever you get to it. 1, 2, -1, -2. Remember, we always have that same set of numbers. So this is -10,000, +10,000. Every single time. So -10,000, +10,000, 0 in the middle. And you're going to shade left until your z-score stops. So in your calculator, it's going to be normal CDF, -10,000, your Z01. So that's what we just learned. To find the area to the right of Z, you're going to use your table, find that area, then subtract 1 from your area. So it's going to be 1 minus area when you have right of Z. So your table only reads from the lower, and only reads the left. And we're going to have to manipulate our calculator to do the right. So there's more than one way to do this. I do it this way. And I'll give you 2 different ways you can do this. And I'm going to tell you the way that I do it. But if this makes sense to you, you do it this way. Okay? So when we're shading in, because I like to shade just to make sure I know to put in the calculator. I still have my -10,000 down here. I have my +10,000 here. And when you shade to the right of Z, it's going to give you a Z, and they want you to shade from that Z on the right side. So we're going to shade right. So that's why it looks like this. We're going to shade right. So if you're using the table, it's 1 minus the area. If you're using the calculator, it's going to be normal CDF. And where is our left? Where's our lowest this time? Our lowest is not -10,000. It's actually Z this time. And then we're going to shade right, and it's like we're not stopping. So since that's the case, it's going to be a +10,000 we're going to stop at this time. We have to tell the calculator to stop somewhere. So 10,000, -10,000, those are just numbers that we just make up. So if you need to change them, you can change them to 1,000,000 or -1 million if you want to. But normally this -10,000, +10,000 works. My mean is 0, standard deviation 1. So the other way I've seen people do this, because they want to do the problems the same way every single time. I've seen people do this. Now I do this, but I've seen people do this. They'll do 1 minus on the outside and they'll do the left of the graph the same way we did before. So they put the 1 minus on the outside, like we do in binomial CDF. So if you get confused about whether to put negative 10,000, positive 10,000, you can do the negative 10,000 every single time and do 1 minus when it's right, just like we did for binom CDF. Okay, I do this, but you are able to do that if you like. Okay. Then the last is the in between. So with the in between, we're looking between two z-scores. So for the table, to find the area between two z-scores, find the area corresponding to each of the z-scores, then subtract the smaller from the larger. So you're going to do subtraction, area minus area, making sure it's positive. Remember, we have to have a positive area. So this is area minus area. When you're graphing, it's going to just be between two numbers. Your graphing is between those two z-scores, wherever they are. You still have your negative 10,000, your positive 10,000. Notice there's no shading on either, so you're not going to use either. You're not going to use positive 10,000 or negative 10,000. You're going to put those z-scores in when you put it in the calculator. The lowest z-score, the highest z-score is 0, 1. So you're not going to have a 10,000. Alright, so let's practice one of each of those. Again, these are taking me longer because I'm going to do both, but you stick with one. It's going to take me longer because I'm doing both, but you stick with one. Alright, first problem. Find the area under the normal curve to the left of z equals negative 0.99. So left tells me I'm going to leave everything as it's supposed to be and work this out. So I like to do a sketch of my graph. You don't have to sketch the graph unless they tell you to, but I like to do a sketch so I'll know exactly what I'm putting in the calculator or what my answer should look like. So z equals negative 0.99. That's almost a negative 1. So like right here, that's z equals negative 0.99. So right before I get to negative 1, and it's telling me to shade left. So I'm using negative 10,000 in my calculator. Let me do the table first. So table, since it's left, I'm going to use that area I see. Left means I'm going to use the area I see. Nothing's going to change. So my last problem, we're working with positives. This is a negative. Let me flip this over and look for negative 0.99. Negative 0.9. And then the 9 is first on this side, and the 0 is first on the other side. So right here. .1611. No technology, no nothing, just went in, got my answer. So So the area is equal to 0.1611. For the calculator, I drew my graph. So I have normal CDF. Remember, we don't use PDF. Negative 10,000. That's the lowest my calculator's going to go. Or negative 1E99. All the way up to Z equals negative 0.99. And then 0, 1. So if you don't like using the calculator, you don't have to use the calculator. You can use Excel, you can use StatCrunch, you can use any of those ways of technology. So that was second vars, negative 1E99, negative 0.99, 0, 1. Double check to make sure that's correct. 0.1611. So just in case they ask you to interpret, or just in case they want you to know what it looks like, or what does this mean. So 16.11, remember, all we want to do is change our answer to a percentage if they want us to interpret as a percentage. So 16.11% of the area under the curve is, we're looking at either greater than or less than. So this is less than because it's left. Less than Z equals negative 0.99. If it was greater than, then it would be greater than. If it was two Z's, it would be in between. All right, we got two more. Find the area under the standard normal curve to the right of Z equals 1.06. Now we have a right problem. So we're shading for these first few problems just to make sure we're good. So 1.06 is probably like right here. This time it tells us to shade to the right. The curve actually goes out beyond 2. Just keep forgetting to put that. So now we have a 10,000 that we're working with this time, because I have my starting point and then I didn't have an ending point, so I made it a 10,000. Here we had an ending point, but we didn't have a starting point. That's why I put a negative 10,000 there. So we're working with right. So the table, we're going to find the area of 1.06, and we're going to do 1 minus that because it's right. And let me kind of show you a trick to make sure you know when you're subtracting 1. I went to my positive side. Something didn't quite look right when I graphed it. Doesn't mean I'm wrong. Just didn't look like my graph does. This just means you're going to do 1 minus because it's not shaded in the same direction. This is left, which is the only way the paper goes, but I need right, so that means I'm doing 1 minus. So you can always check your graph, even on the other side. Check your graph. So I'm going to look for 1.06, so 1.0. 0.8554. 0.8554. My graph didn't look the same, so I'm going to do the opposite of what the graph or what the table says. And you could have done that mentally, but I just wanted to make sure my numbers are right because we work with a lot of numbers. So I just want to make sure my numbers are right. So 0.1446. Now the calculator, again, you could do the 1 minus with the left, but I'm going to put it in just like I see it on my graph. 1.06, 10,000. So I'm reading left to right. 1.06, 10,000, 0, 1. When you listen it, you don't put the commas in. If you have an older calculator, you do put these commas in. That's why I put them in. But after I put it in, the calculator's going to automatically put those commas in. So I just want to match it. So I make sure that I have the right numbers. Second bars, number 2. 1.06, positive 10,000. So you'll never have a negative 10,000 for your upper because it'll never be your highest number. So negative 10,000 can never be your highest number. Make sure that matches. So we have 0.1446. All right, let's do this last one. So this last one's going to be an in-between problem. The spacing got a little off when I was printing these out, so I have to do a little better next time. All right, so that's the practice problems on the bottom. Let me see if I can blot it out some kind of way. Okay, there we go. Find the area under the standard normal curve between z equals negative 1.5 and z equals 1.25. So again, I didn't give myself enough room to do this, so let me do the best I can. So z equals negative 1.5. And z equals 1.25. So in between those. So I need to find those two areas. And just subtract the largest one from the smallest one. So it doesn't matter which one you find first. So I'm on the positive side. I'm going to look for 1.25. This is 0.8944. The other area is negative 1.5. So that's going to be negative 1.50, negative 1.50. So you have to have that number on the end. If you don't, just make it a 0. Point 0.0668. I'm going to subtract those answers to get my actual area. If I put them in my calculator right, I might get them right. 0.8944 minus 0.0668. So the largest one from your smaller one. Doesn't matter when you find them, but you do have to subtract them in the correct way, because remember, we can't have a negative area. So 0.8276. So for the calculator, we're going to put in our lowest and highest z-scores. So notice neither end is shaded. So we're not going to put in a negative or positive 10,000. We're going to put in negative 1.5. We're going to put in 1.2501. Negative 1.5, 1.2501. 0.8275. So remember, it may be a smidgen off because the paper is finite. Those are rounded numbers, but the calculator gives us the exact answer. All right, so don't worry about that. So what if you like to have negative 1E99 in there? So remember, we changed it. So it's not in there now. If you clear that first lower bound and then quit second mode, it will reset your calculator to normal CDF with a negative 1E99. So let me do that again. So you're here and you want that number to just come back. You're going to clear that second mode and go back in. And voila, it's there.